So welcome to the first episode of Solving Data Structures exercise with me. For today, as this is the first episode, I've decided to find something easy because I'm not an expert in this topic or any other software development topic, but I like to share some useful stuff with people. Uh, okay, this one was on HackerRank. The level is really easy. I still did not solve, and I will try to solve here with you. Um, okay, let's try to understand the problem first, because this is the most important thing to do when you are trying to solve something. Try to understand the problem. Okay, given two pointers to the head nodes of two linked lists, I think I will increase a little bit my font to be visible for everyone. Okay, given pointers to the head nodes of two linked lists that merge together at some point, find the node where the two lists merge. Okay, from this sentence, I can understand a little bit of the problem, what we are trying to accomplish. We have two lists and we want to find the node where the two lists merge. Cool. The merge point is where both lists point to the same node. Okay? They reference the same memory location because this is really how linked lists uh, work, right? You have like, I can actually explain what is a linked list after reading all this problem, but they have different nodes, which nodes are some memory locations, basically. Uh, if the list shares a common node, return that node's data value. Okay. After the merge point, both lists will share the same node pointers. I think I got the whole problem from the initial sentences, so I think we can try to solve it. Okay, they give like here two examples. You have list one with these nodes, and from here you have, okay, this is basically the merging node where both meet, right? Function description, complete define merge node function in the editor below. Okay, we have this editor here. I've selected Java 7. I prefer to use Java to solve data structures problems, although I like Kotlin, but because of Java's verbosity, it's really easy to understand data structures and what you are trying to accomplish. Okay, we have head one. This is a pointer to head one and to head two. Nice. And this function returns an int that is the data value of the node where the list merges. Okay, it returns an int. So why is it showing this error? Okay, it returns an int, and for now it's not returning anything. So I will put return 0 for now. Nice, the error is gone. The input format, do not read any input from studying or console. So, okay. The first list contains an integer t, the number of test cases. I think this is this stuff that normally is around here, so we don't really care about it. Okay, let's check some other stuff here because This is a lot of things that really don't matter for now. And let's check the constraints. Head 1 and head 2 are different from null. Head 1 and head 2 are different. Okay, that means that this one will not be null, this one will not be null initially, and these ones will not be equal initially. Cool, nice for knowing. Sample input. The diagrams below are graphical representations of the lists that input nodes head 1 and head 2 are connected to. Test case 1, okay, this is the merging point. Oh, on test case 1, they give you like lists that have the same number of nodes. From what I can see here, and in the test 2, the first list has 2 nodes, and the second one has 1 node. Okay, cool. Sample output, it's the output for these ones. The merging node here is 2, and the merging node here is 3. So this would be the output 2 and 3. Okay, I think I got this. So let me explain a little bit for those who don't know what a linked list is. I've opened this auto draw thing to be drawing like data structures or any other problem solving mechanisms or approaches that we want to follow, right? So I'll be doing it here. So the maybe the easiest way of representing a data structure would be by doing something like that. Okay, first of all, what is a data structure? Data structure is a way that data can be organized in your computer, basically. And uh, linked list is one data structure. Linked list consists of nodes, right? So we have, I think I can paste it many times. Suppose that these are nodes, right? These rectangles here. I want to draw something here. Okay, so a node, I'll write here, node. This is a node, right? A node consists of data, for example, a number, a text, a character. It's a data, or can be a more complex object, right? So the data would be here. Here, since they talked about numbers, I will put a number, 10, and the next compartment of the node has the reference to the next node. So this one would be pointing to this node. Means that this node only has information of the next node because of this compartment that in the end of the day is a field or a property of the node class. And the same happens to this other node. It knows about this node here. So we can put some other data here. I'll put 5, and here I will put 0. And in the end, when it finishes, since this is the last node, you'll have null. So we don't have a node in the end. That's how we know what's the end of a linked list. I think this explanation was nice. I hope it's clear for you if you are watching this. Okay, let's go back. So here, let me just reduce my font a little bit, resize it to be nice for me also. Okay, we have head 1 and head 2 given here. So how can we try to solve this? I thought about doing something now. So let's draw something else here. I'll draw a list, not like a linked list with these connections, but let's suppose that this is a linked list, right? It's a collection. And we have another linked list. So they gave us head of linked list 1 and head of linked list 2. The head of linked list 1 is this one, and head of linked list 2 is this one. If we want to find the merging point, I think that we would have to go through each compartment, right? Each node of the linked list 1 and compare with each node of linked list 2. That will be something like that. The first thing that we would do would be maybe compare these two. They even say here that head 1 and head 2 are different, but it's okay to compare. I think that there's no problem if we compare these two, just to make sure. And will be easier even to write the code if we compare these two. Okay, if these two are not equal, we want to compare this one with the second of this list. If they are not equal, we want to compare with this one. If they are not equal, we want to compare with this one, and so on. And if they are not equal to the head of node 1 or the initial node of list 1, I mean, we will need to compare the second, right, to the first here, 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 and here. If we don't find the matching node, we need to go through the rest of nodes of list 1 and do this comparison. I think this is the best approach to solve this problem. But we know this is all software, this is all about algorithms, so there should be another approach that's better than this one. But for now, I think that this one is the most reliable for this case. So we need to have a loop, right? So I want to go through the list 1. We are given the head of the list. So while head 1 is different from null, right? Since it's a loop, I can come here and say that head 1 equals head 1 dot next. So this thing would go through all these nodes. For example, if I put something like print here, I can print all these nodes. but now we don't want to print. We want to compare this node to this node of list 2. So I can have another loop or iteration I can call like this, I don't know, but we want to iterate through head 2. So while head 2 is different from null, okay, we were here, head 1 comparing to head 2, right? So we need to do this comparison. If head 1 is equal to head 2, what they want here, they want us to return the data value of the node where the list merged. Let's suppose that they merge here. So we would pick one of these two nodes, right? And just return these data. Okay, it could be head 1 also because they should have the same value if we manage to pass this comparison here. So else, I can even skip like the else and write it here. We don't need an else. Head 2 would be head 2 dot next. We are looping through head 2 also. And I think that this solves the problem. Yes, let's run. Okay, we have a wrong answer. So we need to figure out where the issue is. So let's go back and check what was the approach that we decided. We compared the first node with all the nodes of list 2, right? So if we are here, okay, I found the issue. So when we are looping when we are iterating through the second list, we forgot to do something. We are changing actually this value here, right, when we don't find. But if we had this as a temporary node, right, I can create here like temp head 2 equals to head 2. And instead of using head 2 and modifying its value, when we finish one of these iteration, we come here and we find the head 2 still being here, right? The list 2 will still give us the first node and not any other node. So I can replace the usage of head 2 with temporary head 2. Okay, so this one definitely should work. Null pointer exception. Where do we have a null pointer exception? Head 1, different from null. Head 2, different from null. Okay, I found the issue. We forgot to replace the head 2 here with temporary head 2. This may solve the issue. But the biggest issue that we had here is that we didn't replace the head 2 with temporary head 2. Okay, now let's run. Okay, the test cases have passed. I was so I was questioning myself what would be wrong here. So for this first exercise, that's it. Let me submit the code. All the test cases passed. And okay, I can go to the next challenge that I will continue in the next video. Thank you for watching. Ciao.